Hello, my name is Daniel, and today I will be going through the AMC 10A from the year 2008 together. And so let's just start. Problem 1. A bakery owner turns on his donut machine at 8:30 a.m. At 11:10 a.m. the machine has completed 1/3 of the day's job. At what time will the donut machine complete the job? Okay, so it said that 1/3 was completed in 11:10 minus 8:30, so it will be 2 hours. 2 hours and 40 minutes. And so one whole would be multiplied by 3, right? So it's 6 hours and 120 minutes, which is 8 hours since he started. So 8:30 a.m. plus 8 hours equals 4:30 p.m., which is D. Problem 2. A square is drawn inside a rectangle. The ratio of the width of the rectangle to a side of the square is 2 to 1. So there's a rectangle and there's a square. Like this maybe. The ratio of the width to a side of the rectangle is 2 to 1. So basically it would be like this, and then if it was divided into eighths, then this would be one part of it. Okay, so this would be the square, and then what percent of the rectangle's area is in the square? So it's 1/8 of the area. It says percent, so times 100 equals 25/2, which is 12.5%. The answer is A. Problem 3. For the positive integer n, let bracket n denote the sum of all the positive divisors of n with the exception of n itself. For example, bracket 4 is 1 plus 2 equals 3, and bracket 12 is 1 plus 2 plus 3 plus 4 plus 6 equals 16. What is bracket 6? Okay, but one thing we know that is 6 is a perfect number, which means that so the divisors of 6 except 6 itself is they sum to 6. So in this case, this means that bracket 6 equals 6. So triple bracket 6 would still equal 6. So the answer is A. Problem number 4. Suppose that 2/3 of 10 bananas are worth as much as 8 oranges. How many oranges are worth as much half of 5 bananas? Okay, so 20/3 bananas equals 8 oranges. 20 bananas are 24 oranges. 10 bananas divided by 2 are 12 oranges. And how many oranges are worth as much as half of 5 bananas? So 5/2 bananas equals divided by 4, right? So it's 3 oranges. The answer is C. Number 5, which of the following is equal to the product this? And right away we can see that these two cancel all the way to here. So it's 2008/4, which is 502. The answer is B. Problem number 6. A triathlete competes in a triathlon in which the swimming, biking, and running segments are all of the same length. The triathlete swims at a rate of 3 kilometers per hour, bikes at a rate of 20 kilometers per hour, and runs at a rate of 10 kilometers per hour. So since they are all the same length, then let's say that one segment has length x. Okay, so the total length would be 3x, and then since we want the average speed, we'll divide this by the time. The total time is 3 kilometers per hour, right? So it's x over 3 plus x over 20 plus x over 10. This equals 3x over 60, and then 20x plus 3x plus 6x. This equals 29/129x under 180x, right? So it's closest to the triathlete's average speed. So this is 180/29, which is close to 180/30, right? So it's 6. The answer is 6. It's D. Problem number 7. The fraction 3 to the 2008th power squared minus 3 to the 2006th power squared over 3 to the 2007th squared minus 3 to the 2005th squared simplifies to. Okay, so this is 3 to the 2000, no, let's just say it's 9 to the 2008th minus 9 to the 2006th over 9 to the 2007th minus 9 to the 2005th, which is basically 9, right? So the answer is 9. It's E. Number 8, Heather compares the price of a new computer at two different stores. A offers 15% off the sticker price, followed by a $90 rebate, and store B offers 25% off the same sticker price with no rebate. Heather saves $15 by buying the computer at store A instead of store B. What is the sticker price of the computer in dollars? Okay, so store A would be 15% off, right? So 0.85. And then if the sticker price is X, it's 0.85X, $90 rebate, so minus 90. B would be 25% off the sticker price with no rebate, so it's 0.75x. And it says that $15, so she saves $15, so 0.85x minus 90. This is $15 cheaper than 0.75x, right? So it's 0.75x minus $15. So 0.1x, because this came here. This is 90 minus 15, so 75. So x equals 750. The answer is A. Number 9, suppose that 2x over 3 minus 6 over x is an integer. Okay, so this is 4x over 6 minus x over 6, which is x over 2. So which of the following statements must be true about x? Then, so if this is an integer, then x must be even, but there are no other conditions. So it's even but not necessarily a multiple of 3, so it's B. Problem number 10, each of the sides of a square S1 with area 16 is bisected, and a smaller square S2 is constructed using the bisection points as vertices. Okay, so what we're talking about here is that we have got a square, and it's bisected, right? So there's this point here. Oh. There's this point, this point, and then this point, and then this point, and then this point. My drawing is not great, but so this is area 16, right? So this has 4 on one side, 4, and then it's bisected. So this is 2 and 2. This was 2 root 2. So this is 2 root 2. The same process is carried out on S2. So they're doing it like this again. So this would be, since this is root 2, this is root 2, this is root 2, this would be 2. So this area of S3, this is S3, right? S3 equals 2 squared equals 4. The answer is E. Problem number 11, while Steve and Leroy are fishing 1 mile from shore, their boat springs a lake. Water comes in at a constant rate of 10 gallons per minute. The boat will sink if it takes them more than 30 gallons of water. So Steve starts rowing at a constant rate of 4 miles per hour. Leroy bails out water. What is the slowest rate at which Leroy can bail if they are to reach the shore without sinking? Okay, so it's coming in 10 gallons per minute, and then they're fishing 1 mile from shore, and Steve is rowing at 4 miles per hour. So so they will get to shore in 15 minutes. So so if Leroy does not bail, then water would come in 150 gallons, but it can stand up to 30 gallons, right? So minus 30 gallons. And then it's over 15 minutes, right? So gallons per minute, so over 15. This is 120 over 15. This is 8 time, no. This is 8, yeah. So the slowest rate that he can bail is 8 gallons per minute. So the answer is D. Problem number 12, in a collection of red, blue, and green marbles, there are 25% more red marbles than blue marbles, and there are 60% more green marbles than red marbles. Suppose there are red marbles. What is the total number of marbles in the collection? Okay, so there are red, blue, and green marbles. 25% more red than blue. Okay, so red, blue, green. And then since there are 25% more red than blue, So the ratio would be 5 to 4. And then there are 60% more green marbles than red marbles, right? So green to red is 60%, so it's 1.6 to 10 to 1. So it's 16 to 10, 8 to 5. So green to red is 8 to 5, so green must be 8. If there are red marbles, then the total number of marbles in the collection are, okay, so this is R, so 5 is R, and total is 17, so which is 17 over 5R, which is 3.4R. So it's C. Number 13, Doug can paint a room in 5 hours. Dave can paint the same room in 7 hours. Doug and Dave paint the room together and take 1 hour break for lunch. The total time in hours required for them to complete the job working together. Okay, so Doug can paint the room in 5 hours, so Doug works 1 over 5, then Dave works 1 over 7. So if they work together, it will be 1 over 5 plus 1 over 7, and then they take a 1 hour break for lunch. So this would be their hours, number of hours, minus 1 since 1 hour is break. So since the number of hours is t, then it's t minus 1. Like this. So this would be D. Number 14, older TV screens have an aspect ratio of 4 to 3. That is the ratio of the width to the height is 4 to 3. The aspect ratio of many movies is not 4 to 3, so they are sometimes shown on television screen by letterboxing, darkening strips of equal height at the top and bottom of the screen as shown. Suppose a movie has an aspect ratio of 2 to 1 and is shown on an older television screen with a 27-inch diagonal. What is the height in inches of each darkened strip? So it says the aspect ratio is 2 to 1 and their diagonal is 27 inches. This much is 27. That means height of TV would be 3 over 5 times 27. This is 81 over 5. And then the TV base length would be 4 over 5 times 27, which is 28, so it's 108 over 5. And then this would also be the movie aspect ratio, right? So movie height, which basically means this length, would be 1/2 of the TV base, right? So this is 108 over 5, so it's 54 over 5. And older TV screen with a 27-inch diagonal. Okay, so the height in inches of each darkened strip is the TV height minus the movie height, right? 81 over 5 minus 54 over 5, and then this divided by 2. This is 81 minus 54 is 27, right? So it's 27 over 10. So it's 2.7. The answer is D. Number 15, yesterday, Han drove 1 hour longer than Ian at an average speed 5 miles per hour faster than Ian. Jan drove 2 hours longer than Ian at an average speed 10 miles per hour faster than Ian. Han drove 70 miles more than Ian. How many more miles did Jan drive than Ian? Okay, so let's say that Ian drove for X hours at A miles per hour. Then Han would drive, so he drove in total AX miles, and Han would have driven X plus 1 hours and 5 miles per hour faster, right? So 5 plus A miles per hour. This would be X plus 1, A plus 5. And then Jan would have driven 2 hours longer than Ian, so X plus 2 hours. And then 10 miles per hour faster than Ian, right? So 10 plus A miles per hour. This is X plus 2 times times A plus 10, right? This would be AX plus A plus 5, X plus 5. and this will be ax plus 2 times a plus 5x plus 20. Han drove 70 miles more than Ian. Okay, so this minus this. So a plus 5x plus 5 equals 70. A plus 5x equals 65. So 2 times a plus 5x equals 7 equals 130. So this would be ax plus 130 plus 20, so it's 150. And so how much more miles did Jan drive than Ian? So this is ax plus 150 and ax. So he drove 150 more miles. The answer is D. Number 16, points A and B lie on a circle centered at O, and AOB is 60 degrees. A second circle is internally tangent to the first and tangent to both OA and OB. What is the ratio of the area of the smaller circle to that of the larger circle? Okay, so if A and B are on a circle centered at O, this is O, and AOB is 60, so this would be B, and since it's 60 degrees, it will be like this, A. And then a second circle is internally tangent to the first and tangent to both OA and OB. And then tangent to both OA and OB, what is the area of the smaller circle to that of the larger circle? So if this is if this radius is R, then this would be R, and since this is 60 degrees, and this would be bisecting it. So if we put a line here, then this would be 30 degrees, which means that this would be 2R. So this distance would be 2R, and this distance would be R, right? So the radius of the whole thing would be 3R. And so the ratio of the area of the smaller circle, so this would be pi r squared, and to that of the larger circle, this would be pi times 3r squared, which is 9 pi r squared. So the ratio of the area of the smaller circle to that of the larger circle is 1/9. The answer is B. Number 17, an equilateral triangle has side length 6. What is the area of the region containing all points that are outside the triangle but not more than 3 units from a point on the triangle? This would be an equilateral triangle with side length 6. And then the area of the region, all points outside the triangle. Okay, so what we have to do here is we have to make a rectangle like that, and then it would have 3 curves. And so what we're trying to get is the area of this whole area, this whole part, right? And so since the side length is 6, this will be 6, this will be 6, and then it says more than 3 units, so this is 3, this is 3, and that basically tells us all that we need to know. So first, the area of these would be, so if these three, if these are like all tied together, then it will make one perfect circle, right? So it will be area would be 3r, 3 squared pi, which is 9 pi. And this area, there are 3 of the same thing, right? So it will be 3 times 6, right? 3 times 6, which would be 54. So it's 54 plus 9 pi equals 54 plus 9 pi, right? So the answer is B. Number 18, a right triangle has perimeter 32 and area 20. What is the length of its hypotenuse? Okay, so let's just draw a right triangle and say that this has A and B, and since the perimeter, A, B, and C, so obviously a squared plus b squared equals c squared, and then c equals 32 minus a minus b. Area is 20, so AB equals 40, right? And then the length of its hypotenuse, so what we're trying to get is a plus b. So if we square these, then c squared would be a plus b squared minus 64a plus b plus 32 times 32, right? 1024. And so a squared plus b squared equals a squared plus 2ab, which is 80, plus b squared minus 64 times a plus b is 32 minus c, right? 32 minus c plus 1024. If we take out these two and these two, 64 times 32 minus c will equal 80 plus 1024, so it's 1124. No, it's 1104. So 32 minus c equals, so this is 69 over 4. C equals 32 minus 69 over 4, which is, let's get rid of this. And this is 128 minus 69 over 4, which is 59 over 4. The answer is B. Number 19, rectangle PQRS lies in a plane with PQ equals RS equals 2 and QR equals SP equals 6. The rectangle is rotated 90 degrees clockwise while R and then rotated 90 degrees clockwise while the point S moved 2 after the first rotation. Okay, so first it's going to be like this, and then this is PQRS, right? And then it's going to rotate 90 degrees clockwise about R, and then so this will be coming like this, right? And then since this would be the new S point, rotated 90 clockwise about that, so this would be about like this here, and P would be here, and the P would be here, right? So the length of the path traveled by point P, so the first would be from here to this point, and then it would be like this, and then this side equals to this side, right? So it would also be like this. And so the length of the path traveled by point P, since PQ is RS is 2 and QR is SP is 6, so this is 6, this is 2, so this length would be 2 roots 10, and so traveled by point P would be, length of path is 2 root 10 times 2 times 1 over 4 pi, so this is root 10 pi, and then length of path for here, this plus, it would be, this is 6 and this is 6, right? So it's 4, so it's 1 over 4 times 12 pi, which is root 10 pi plus, and then this will be 3 pi, right? So this is 3 plus root 10 pi. The answer is C. Problem number 20, trapezoid ABCD has bases AB and CD and diagonals intersecting at K. AB equals 90, C equals 12, and the area of AKD is 24. Okay, so that would be, so this would be A, B, C, D, and then this would be K, right? Suppose that AB is 9, DC is 12, and then AKD is 24. Okay, so if AB to CD is 9 to 12, and these triangles are similar, then what that must mean is that AK to CK is also 3 to 4, because this is 3 to 4, so this is 3 to 4, and then BK to DK would also be 3 to 4. Right, so since this is, the ratio is 3 to 4, and this ratio is 3 to 4, so it's 4 to 3, which means that ABK, this is 24 divided by 4 times 3, which is 18, and then this is 3 to 4, so this is 24 again, And so this is 24 divided by 3 times 4, which is 32. So what we have to do is add these four numbers together. 18 plus 24 plus 24 plus 32 equals 50 plus 40, 40, no, 50, no, it's 40 plus 50 plus 48. Yeah, this is 98. The answer is D. Problem 21. A cube with side length 1 is sliced by a plane that passes through two diagonally opposite vertices AC and the midpoints B and D of two opposite edges not containing A or C as shown. Okay, so the area that we're trying to get would be the area of this here. And so what we need is this length and this length, right? Because those two, if B, so the area of quadrilateral ABCD would be BD times AC times 1 over 2, since this is a right angle. So since this is a cube with side length 1, this has 1 and 1, so this would be 1 and 1, right? Which means that BD would be root 2 and AC would be root 3, since this is root 2 and this is root 1, so this would be root 3. So BD times AC times 1/2 is root 2 times root 3 times 1 over 2, which is root 6 over 2. The answer is A. Number 22, Jacob uses the following procedure to write down a sequence of numbers. First, he chooses the first term to be 6, and to generate each succeeding term, he flips a fair coin. If it comes up heads, he doubles the previous term and subtracts 1. If it comes up tails, he takes half of the previous term and subtracts 1. What is the probability that the fourth term in Jacob's sequence is an integer? Okay, so let's say the first term is 6 because it said so, and then if he flips the fair coin, okay, so if he comes up heads, this is heads, this is tails, he will double the previous term and subtract 1, so this will be 11. Half of the previous term and subtracts 1, this would be 2. Here doubles the previous term and subtracts 1 would be 21. Halves the previous term and subtracts 1 would be 9 over 2. This would be doubles and subtracts 1, so it's 3. Half and subtracts 1, this would be 0. And then this would be 21, double it, and then this would be 41. This would be 19 over 2. This would be 8. This would be 4 over 9 minus 1, so it's 5 over 4. This would be 3 times 2, so it's 5, and then 3 divided by 2 minus 1, this is 1 over 2, and this will be minus 1 and minus 1. So the probability that the fourth term in Jacob's sequence is an integer will be 1, 2, 3, 4, 5, 5 over 8, so the answer is D. Number 23, two subsets of the set A, B, C, D, E are to be chosen so that their union is S and their intersection contains exactly 2 elements. In how many ways can this be done, assuming that the order in which the subsets are chosen does not matter? Okay, so two subsets of S are to be chosen so that their union is S and their intersection contains exactly 2 elements. So their union has to be S. Oh, so the important part is their intersection contains 2 elements. So first we can choose 2 elements from S to be the common elements. So it's 5, choose 2, this is 10. And then let's say A and B is chosen. Of the remaining 3, it has 2 ways to go. So there is first one, and then there's the second one, and then let's say it's A, B, right? So it's A and B are here, so C, D, and E are left. C could go into here or here, D could go into here or here, E could go into here or here, so it has 2 ways each. This is 2 to the 3rd power, but then it has to be divided by 2, since C, D, E all coming here and C, D, E all coming here are the same thing. C, D, and E are the same thing as E and C, D, so it has to be divided by 2. So the answer is 10 right here, multiplied by this thing. So it's 2 to the 3rd power over 2. This is 10 times 2 to the 2nd power. This is 40. The answer is B. Number 24, let k equals 2008 to the 2nd power plus 2 to the 2008th power. Okay, so for us to get this, then we first need to know units digit of k, and then this will be the units digit of this one is 8 squared is 64, right? So it's 4 plus, and then this would be so the units digit of the what do you call it, of the powers of 2, so they rotate in 2, 4, 8, 6, right? And since 2008 is a multiple of 4, this would be 6, so the units digit would be 0. So the units digit of k squared in this part, this will be 0, so it doesn't matter. And so for us to know the units digit of 2 to the kth power, we need to know what the remainder is when k is divided by 4, right? But k is 2008 squared plus 2 to the 2008 power, which is 2 squared times 1004 squared plus 2 squared times 2 to the 2006th power. This is 4 times 1004 squared plus 2002 to the 2006th power. So k is 4 times something, right? So k is a multiple of 4. This means that 2 over k has a units digit of 6, so the answer is D. Problem number 25. A round table has radius 4. 6 rectangular placemats are placed on the table. Each placemat has width 1 and length x as shown. They are positioned so that each mat has 2 corners on the edge of the table, these 2 corners being endpoints of the same side of length x. Further, the mats are positioned so that the inner corners each touch an inner corner of an adjacent mat. What is x? Okay, so what we want is this line x, right? And so first let's draw some lines from this point to that point, and we'll draw one more line from here to here, and that will give us the center, which is this point, right? And so from there we'll draw a line from the center to this point. That will be like this, and one more line from this center to here, because that is the key to solving this problem, right? And so we find that we have a right triangle here with this as a right angle, and since this whole length is x, then half of that length, that will be 1/2 of x, right? So this will be 1/2 of x, 1/2 of x, right? And then and this is 1, right? Obviously, because this is 1, because this length is 1, so it's the same length, so obviously it's 1. And since this is a equilateral triangle, we can know that okay, so let's do it somewhere else. Since this same triangle is same as this triangle, we know that this length is the same as this length, right? So for easier comprehension, I'll just draw that here, and let's find the length of this blue line. And so for that, since this is x, right? So this is x, and this is half of x, and since it's 2 to 1 to root 3, it will be root 3 over 2x, right? And so now we know that this length is root 3 over 2x, right? And so if we take this out, that would be like this, right? That would be the right triangle, and then this would be half of x. Let me get rid of this. And then this would be 1 plus root 3 over 2x, and this would be r. This would be the radius. What did it say the radius is? It has radius 4, right? So this is 4. And so now we know that 4 squared equals half x squared plus 1 plus root 3 over 2x squared, right? Because this is the Pythagorean theorem. So obviously 16 equals 4 under x squared. So x squared over 4 plus, let's spread this out. That will be 1 plus root 3 x plus 4 under, so 3 over 4 x squared, right? And so this will be 1 plus root 3 x plus x squared, because that's grouping this and this together, right? And so this would equal 16. And so let's move 16 over here, and say x squared plus root 3x minus 15 equals 0, and we need x, right? And so we have the formula, right? And so it's 2a under minus b plus or minus root b squared minus 4ac. And so if we just put these in here, then we get 2 and all over 2. B is root 3, so it's minus root 3 plus minus root 3 minus 4 times minus 15, which gives us 2 minus 3 minus root 3 plus or minus root 63. And then we can't have the value be a minus, right? Because that would mean x is negative, but x is a length, therefore it has to be positive. And so we can say that this is plus root 63. 63, yeah, let's just change the order, minus root 3. And so 63 is 7 times 9, right? So this is 2 all over 2. 3 root 7 minus root 3, that's this. And if we find it's C, the answer is C. Thank you for watching.